Hello guys, welcome back to my channel. My name is Gede Sunanjaya. My number, my student identification number is 230553107. My lecturer is Prof. Dr. Tjokorda Gde Tirta Nindhia, STMT, MENG from subject Metallurgy, TM2301. And today I will show you my presentation. So guys, this is my presentation about fabrication and finishing of metal products. So my base references from book Metallurgy for Non-Metallurgists edited by Arthur C. Reardon. So metal products that are subject to mechanical reduction versions subsequent to casting and solidification are referred to as worth products. These products can be shaped, finished, and assembled by using a variety of metalworking technique, which may include method from forming materials, removal, and joining. This chapter describes in limited detail these metalworking technologies, bulk forming of metal in the production of work product, sheet forming and bending of metals, a powder processing to consolidate and densify powder into net-shaped part, material removal process such as drilling, milling, cutting, and grinding, and last, joining process such as welding, soldering, and brazing. Deforming process. In metalworking process, a work piece such as billet or blank sheet, for example, can be plastically deformed by a set of tools or dies to obtain the desired final thickness and geometrical configuration. Metal forming process can be classified into two general categories: bulk or massive forming operation, bending and sheet forming operation. Sheet forming is sometimes simply referred to as forming. In the broadest and most accepted sense, however, the term forming can be used to describe both bulk deformation process, sheet forming, and bending process. The major distinction between bulk and sheet forming is the nature of the resulting deformation. Bulk forming operation typically involve multi-directional deformation throughout the volume of the work mass. The generic types of bulk working method include extrusion, forging, rolling, and drawing. Some methods such as open die forging and radial forging are used in both primary mill production and in the production of finished part. In contrast to bulk forming, sheet forming typically involve local deformations. During sheet forming, a piece of sheet metal is plastically deformed by tensile loads into a three-dimensional shape, often without a significant change in its thickness or surface characteristics. Examples of sheet forming process include deep drawing, stretching, and bending. Sheet metal typically is formed into end products with various contoured shapes, ranging from saucepans to car bodies. Metal forming equipment. Metal forming is done with a large variety of machine or equipment such as rolling mills for plate, strip, and shape, machine for profile, rolling from strip, ring rolling machines, thread rolling and surface rolling machines, magnetic and explosive forming machines, drawing bench for tube and rod, wire and rod drawing machines, machines for pressing types operation of presses. Among those listed pressing types, machines are the most widely used and are applied to both bulk and sheet forming process. Primary production mills. In primary production operation, the initial stage of metalworking involves breakdown of cast structure into worth of work forms. Starting material is usually either that ingot from static or stationary mold, casting or continuous cat slab or billet. With conventionally cast ingot structures, workability is very low due to relatively coarse microstructure and intensive segregation of impurities. Thus, ingots undergo primary production step that consists of either forging or whirling or ingot breakdown, as they are processed into semi-finished shapes or blooms, billet, and slabs. Continuously cast alloys require no primary reduction step. The next step is the mill processing of blooms, billets, and slabs to produce various product forms such as plates, sheet, strip, and bar. Ingot breakdown. Many ingots continue to be statically cast because not all ferrous and non-ferrous metals are capable of being continuously cast due to their relatively coarse and inherently weak microstructure. The temperature range over which ingot structure can be formed is very limited. Forging. In its basic form, forging consists of applying compressive stress to a piece of metal, known as a workpiece, between a pair of dies in order to permanently change its physical dimension or geometry. Large forging are processed by primary mills, but forgers also purchase raw products in the form of bars, billets, or bloom for subsequent forging on hammers and presses. Various types of forging process are listed in table. Open die forging, roll forging. Advantage. The basic advantage of roll forging process include continuous production of forged product, improved grain flow, better surface finish and breakdown of scale in steel forging, perform mass distribution that save material, reduce flash, increase die life, and reduce cost in subsequent finish forging operation. Radial forging, hot offset forging, and last cold forging. Drawing and extrusions. Drawing and extrusion are based respectively on the pulling and pushing of section through dies. In the drawing process, the cross-sectional are and or shapes of a rod, bar, tube, or wire is reduced by pulling it through a die. The deformation is accomplished by a combination of tensile that compressive stresses that are created by the pulling force at the exits from the die and by the die configuration. Metal flow during extrusions through a conical die is analogous to drawing because the metal is forced through the die region. The first drawing is one of the oldest metal forming operation to make long product with excellent surface finish and closely controlled dimension and constant cross section. Extrusion is the deformation process used to produce long, straight, semi-finished metal product such as bars, solid and hollow section tubes, wire and strips. Extrusion have two types. There is hot extrusion technology and cold extrusions. Forming metal bar tube plates sheets are formed by various bending, stretching, and drawing operations. Bar and tube are formed mainly by bending operations such as compressions, bending, stretch bending, draw bending, and roll bend. Spring back is a major factor in forming operation. As an example, consider a simple bend. The tensile stress is a maximum at the outside surface of bending decreases toward the center of the sheet thickness. The stress is a zero on the neutral axis. In bending, we can find method of counteract the effect of spring back are overbending, bottoming or settings, stretch bending. Sheet metal is often overbent by an amount sufficient to produce the desired degree of bend or bend angle after spring back bending of bar and tube. The four basic methods of bending bar tube stock are compression bending, draw bending, stretch bending, roll bending. Powder metallurgy. Powder metallurgy is a growing branch of metallurgy based on the production of material is the form of metal powder and the manufacturing parts from these materials. The most common method of parts production is a two-step process of powder compression by pressing and densification by sintering and referred to as PM pressing and sintering. Fabrications of parts by PM method has several advantages that include producing parts with more uniform microstructure and distribution of alloying elements, high volume production of parts with net shape or near net shape dimension, thus reducing of the need for finishing and less flexibility in component design. Material removal processes. Material removal process of which machining is a special class or secondary manufacturing operation used to achieve precise tolerance and controlled by surface finish inequality. Then are three basic classes of material removal: conventional machining operations, turning, drilling, milling, boring, planing, shaping, reaming, and tapping, where material is removed from the workpiece in the form of shape. Abrasive process such as grinding and honing, where small particles are removed from the workpiece by abrasion with a hard tool.